So welcome to the Node.js Node API team meeting for June 9th, 2023. We're going to kick off the meeting with a demo from Jason about, I think it's .NET integration with add-ons. And then we'll go back to our regular agenda. So I'll hand it over to you, Jason.
Hey, thanks. Hi, I'm Jason. For those of you who don't know me, I was one of the early members of the Node API working group. Did a lot of the early implementation for Node API and the C++ wrapper. I've been absent for a few years working on other things, but last fall kind of got inspired to start this project for .NET and JavaScript interop using Node API. So Vladimir and I have been working on this for a while, and it's come together pretty nicely, and so I'll tell you about it. Sharing my slides here. So Vladimir, if you want to jump in at any point, let me know.
Okay.
So generally, we just want to build a system for better interoperability between .NET and JavaScript. So .NET and JavaScript are often used complementary in complementary ways. But so far, there's never really been a great way to interop between them. Interop is typically always out of proc using some kind of RPC mechanism. But there's not a great way to interop in the same process so far. There's some limited solutions, but we think we can do a lot better. So there are a few scenarios we're targeting. First one is to just dynamically invoke .NET APIs from JavaScript. So if you have a class library that's written in C# or something like that, you can call them from your JavaScript code without any kind of setup or without that library having been specially designed for being called from JavaScript. So we just want to be able to call basically any kind of .NET APIs from JavaScript dynamically. The second scenario is to build a Node.js add-on module in C#. So this is where the .NET code is specifically designed to be called from JavaScript and perhaps to act like a JavaScript module. And the third one is kind of the reverse scenario where you're hosting JavaScript within a .NET app, whether for extensibility or because you want to use some JavaScript packages from your .NET application. And then kind of a variation of that is building React Native apps in C# with JavaScript interop. And all this works on both .NET Framework and .NET 6 or later, where .NET 6, of course, is cross-platform. It runs on Windows, Mac, and Linux. So the first scenario I mentioned is just dynamically invoking .NET APIs. You can require our Node module and then call .NET System APIs, or you can load .NET assemblies and call use classes and call APIs in those assemblies. And that works pretty well to use almost any APIs. Actually have generic support in review, and so they're like ref and out parameters are one of the only things that is not yet supported in terms of the kinds of APIs that you can use.
Is this like along the lines of FFI? You know what?
Yeah. So
this with C++.
Yes, this scenario, when I say dynamically invoke, it is basically a .NET equivalent of FFI. So it is, yeah, you're calling any APIs from JavaScript to .NET. There's a lot of nice things that we can give you related to that in terms of type definitions for TypeScript. And there's a lot of performance optimizations in that we dynamically generate code, which I'll talk about these things later.
Okay, thanks.
So this is developing Node add-on modules. This is kind of the classic Node API scenario where instead of using C++, you can use C# and specifically define what APIs in your code are exported to JavaScript. And then when you build that, it builds TypeScript type definitions for that, makes it really easy to consume those APIs from JavaScript. And optionally, we can use .NET Native AOT to compile the C# code to native binary, meaning it doesn't any longer depend on having .NET installed at runtime. So I mentioned TypeScript type definitions. We have a tool that will reflect over the .NET APIs that are either specifically exported to JavaScript or .NET assemblies that you're trying to dynamically invoke and generate type definitions for it. And there are MS build scripts to kind of automate that process as part of your build. So first demo I'm going to show is dynamically calling this semantic kernel library from JavaScript. So semantic kernel is a library for working with AI, which is being rapidly developed by the Office team. It's part of what is being used for all the Office Copilot AI services that have been recently announced. So Office team builds a lot of web services in .NET and a lot of services in Node.js. So this semantic kernel library is being developed primarily in C#, but they want to be able to use it from their Node.js services. So this is a way that they can do that. So I'm going to switch over to some code.
Sorry, just a quick question. On the previous page, you mentioned the TypeScript wrapper. So like that, not only do you're supporting FFI where you like do the loads and stuff yourself, you also have a tool that basically will generate you wrapper classes that does that all in the background, right? Is that
right?
Yeah.
Yeah,
Okay,
I can show that right here. So for semantic kernel, we import a couple of these JavaScript files are simply loading the .NET assembly, but the primary thing we get from importing is the TypeScript type definitions, which are, hold on, let me find the directory. So as part of the build process for this project, we generated type definitions for not only the semantic kernel assemblies, but other NuGet package assemblies that those depend on. So all of these JavaScript files, and so the JavaScript file is, pick one example here. So semantic kernel abstractions. So JavaScript file simply uses nodeapi.net to load the .NET assembly, but the d.ts file has all the generated type definitions for all the .NET classes and methods and properties and everything that's in that .NET assembly. So generates type definitions, also extracts doc comments from the .NET assembly, which gives you a really nice experience in your JavaScript code when you're using it. So VS Code, of course, can then give us the type definitions and the doc comments as we're using these APIs in JavaScript. So this example code, it sets up a logger, which is JavaScript code, which is implementing a .NET iLogger interface, passes that logger into the semantic kernel.
Jason, yeah, sorry to interrupt. Are you sharing any code or something?
Oh, sorry, can you not see that?
We just see the slide.
Okay, sorry. I'm not used to using Zoom.
If you were sharing just a window, then yeah, we would only see the window.
Let's try this. Can you see the code now?
That looks much better.
Yep.
Okay. Thanks for interrupting. Yeah, so let me, jump back to what I was showing with the type definitions. Sorry. So as part of the build process for this project, it generated all these d.ts files and JavaScript files, and this DLL is the .NET assembly. So the JavaScript simply loads the assembly using node.api.net, but the d.ts file has all the generated type definitions, which are produced by reflecting over that .NET assembly and the doc comments for it.
I have a question. So so it all starts by requiring this node API.NET, right? And then just simply calling various .NET functions, classes, etc. So those are, so when do you decide which DLLs are needed? Is that some kind of build step that analyzes what is being actually used after the node API.NET has been required, or how do you decide which DLLs to build and which ones to build like d.ts files for?
Yes. Okay. So you have to know which assembly you're referencing directly, but then that one may depend on a whole tree of dependencies, which you don't necessarily know about. So we leveraged MS Build for pulling in dependencies. So this is a CSproj file. Even though there's no C# code in this project, CSproj file sets up the NuGet package references for the assemblies that we directly reference, which is the primary semantic kernel assembly and then our node API generator assembly. And then MS Build will figure out all the dependencies of that. The NuGet package restore will download those dependencies and extract them. Some scripts inside of our generator NuGet package will take care of generating those JavaScript and TypeScript files for all of those dependencies. So then what you get is this bin directory that has everything that you depend on, and the JavaScript and TypeScript glue for those things. Does that make sense?
Yep, but what build system does this on Linux and Mac?
MS Build runs on Linux and Mac. It's cross-platform.
Okay, I see. Got it. Yep, thanks.
So here we're importing these two .NET assemblies, but notice we don't assign the imports to anything. The way we do imports here is by is using .NET namespaces. So .NET programmers are used to working with namespaces, where when you reference a class, you refer to it by a namespace, or you define what namespace your code file is using. So when you import an assembly, the assembly may have multiple namespaces, and multiple assemblies may contribute to the same namespace. So we found that it works best this way, where when you import an assembly, it basically builds up the namespaces on this top level .NET object. So now we have where you can alias these two namespaces there and use types from those namespaces. So this is some JavaScript code which is implementing a .NET iLogger interface. So the .NET interface gets converted to TypeScript. So I can hit F12 and go to the definition of that TypeScript interface, which was generated from JavaScript. And as long as I create a JavaScript object that implements those same methods, then I can pass this object into this .NET API that is expecting a .NET object that implements that interface, and it can do logging that way. So this is just setting up some parameters for the OpenAI service that it's going to call. I've already set up these environment variables for the demo. And for this demo, what it's doing is summarizing some text here. And it's going to give me a short summary. I'm asking it for a 5-word summary. Now, this semantic kernel library is designed to give you a lot of client-side ways to work with AI in terms of giving it memory and constructing different kinds of prompts and composing those prompts together. But this simple example is just doing a straight summarization. So if I run that code, we'll see a bunch of logging followed by the final output, which is robots must not harm humans.
I have a quick question. On line 55, we see that there is the await for invoke async. Do you have some sort of wrappers for tasks to promises?
Yes.
I see. Okay. That's handy.
Yeah. It just kind of works automatically in that this is a .NET API that returns a task, and it gets marshaled back to JavaScript as a promise.
Okay.
And do a wait on that.
Nifty. All right. Thank you.
And so as we know, JavaScript is single-threaded event loop, whereas .NET is a multi-threaded environment. So .NET has a thing called a synchronization context, so that if this API that we're calling spawns another thread and does an await in C#, the synchronization context will make sure that it will return back to the JavaScript main thread. In normal cases, there can be more advanced threading logic where your C# code might need to do something special to work with that. So I'm going to skip that video demo, which was kind of a more elaborate demo from somebody in the Office team showing how they're using that in their services. And then jump to this other scenario, which is hosting JavaScript inside a .NET app. So we can do the reverse. We can host either Node.js or some other JavaScript runtime in .NET. And this is currently leveraging the PR, which adds the Node API style stable embedding APIs. So we built a libnode using those added APIs because C# is not C++. It can't call C++ embedding APIs. We need stable C style APIs to interact with from C#. So I want to talk later about how we can push that PR forward for embedding. But generally, we can, in C#, we can define an interface that JavaScript will implement, and then we can import JavaScript packages and call JavaScript APIs from C#. And I have a demo app that's doing that. So there is a JavaScript package called Fluid Framework, which is used by all the modern Office apps to do collaborative text editing. But it is a JavaScript only app. It was designed first kind of for the web, so that you have collaborative text editing in little web components that can be basically embedded anywhere. So there's no C# API for that, but I was able to build a C# application which uses that JavaScript library to do collaborative text editing. So I don't know if I was prepared to show that demo, but I'll quickly show some of the code at least. So we have this WinUI Fluid example code, and there's some JavaScript code which takes care of kind of setting up this fluid context, and then in our C# code for the actually it's this collab edit box. We can work with these JS value APIs. So a JS value is kind of any kind of JavaScript value. We have more specific JavaScript types for objects and arrays and functions and collections. I don't know if there's any example code for that, but basically the C# code is calling these. This is setting up an event handler and converting between JS map and .NET dictionaries. So I won't go through all this code because it's a little bit more complicated to handle this collaboration, but
is that JS value.create function? Is that like an equivalent to the Node add-on API C++ wrapper, but for .NET?
Yes, it is exactly that.
Okay, so you have like a similar, like, because that kind of looks, we probably have I don't know if it's the exact same format, but like, you know, Rust has their equivalent, and some of the APIs at least look like that, where you say like, hey, I'm going to create a function, I'm going to add that function to an object. And the way I kind of see that level of the API is, as opposed to the FFI, you're effectively writing JavaScript in C#.
Right. Yeah, it's directly working with JavaScript objects in the C# code and essentially really calling the NAPI methods on it. So,
right.
Example, okay. Here's some mappings to the NAPI functions.
Right. That's the implementation of it there. Okay. Yeah.
Yes.
Okay.
Yes.
Thanks.
So I'm going to skip over a few slides in this deck where we explain what Node API is, because you all know what that is. Vladimir, did you want to show this demo?
Yeah, I couldn't make it working.
Okay. You want to talk about it then?
Yeah, the idea was like, Jason just mentioned one of his demo was embedded the whole lib node, but there is something else I'm working as a part of a React Native project. Inside of React Native project, React Native for Windows. So what happened, like Meta is implemented React Native for iOS and Android, and Microsoft implements React Native for desktop. So thankfully we're supporting React Native for Windows and React Native for Mac. But in fact, we have a very close collaboration between Microsoft and Meta. We have like weekly meetings, all these kind of design discussions, because Meta built some of their products on top of our React Native for desktop. So it's extremely close collaboration, the whole project. So what what happens that React Native needs to use different JavaScript engines. React Native started to use JSC. Lately, Meta created new JavaScript engine called Hermes. And also in Microsoft, we're using V8 in some cases. So originally, Meta came up with kind of abstraction layer, how to work with JavaScript engines. They created an interface called JSI. But this is kind of C++ based API, and definitely it's not API safe. There's no nothing like this. So that's why we kind of chose to use Node API to be as our kind of surface to these JavaScript engines we use inside of React Native. So in the course of last a few years, first of all, we borrowed some implementation of Node API for V8. So we do have V8 DLL, which exposes Node API. And we also implemented a Node API on top of a Hermes JavaScript engine created by Meta. We also have implementation for other engines, but this is pretty much two major implementations we use. So this demo is supposed to be like just quickly shows that from our command line C# application, we can invoke Hermes API and we can run JavaScript and stuff. But, yeah, so we can probably, yeah.
So in that context, it's not necessarily add-ons, it's just integration between some native code and JavaScript, and a JavaScript engine.
Right. So idea that we use Node API, we plan to use Node API in two different cases. One of them is a kind of core interface to JavaScript engine. So JavaScript engine has additional APIs to pretty much create instance, configure instance, all that kind of stuff. But always JavaScript communication goes through this Node API there. And also we would like to have Node API to be also kind of common JavaScript surface for add-ons. Like React Native has its own add-on model called, initially it used to be called native modules. Now we have a new specification called turbo modules. And turbo modules, they intend to use this JSI to have effectively direct implementation. And also I forgot to mention, because Node API is C-based API, and for example, even typically in node.js project, we use C++ wrappers around it. In case of React Native, JSI is also in some sense C++ API, and we implemented JSI adapter for Node API. So technically, it's possible that people even can create, we didn't create it yet, but it's possible that people may use JSI to create node.js add-ons, if you like.
Right, yeah.
Just kind of think about it, it's another C++ wrapper around Node API. So yes, we kind of, not only for add-ons, but also for JavaScript engines. And since we have libnode with all this Node API, it's also kind of possible to, in React Native, use libnode altogether. It's also kind of another kind of scenario. We didn't try yet, but we consider to play with it a bit. And this slide is about like a low-level JavaScript interop, just to give some kind of ideas at how it looks like. It's again, this presentation was for people who don't know much about Node API. But what we're saying, we have some low-level objects like JS value, JS object, JS array, JS map, and so on, and which kind of wrap in all this low-level Node API and kind of corresponding JavaScript objects. And then we kind of, whatever Jason talks about, all these different high-level concepts built on top of them. Jason, please continue.
Yeah, most of the time, you won't need to write this level C# code using those JS APIs. You want to write kind of more natural C# code using classes interfaces and map those to JavaScript classes and so on. So we have a lot of automatic marshaling for all different kinds of types. And we pass classes and interface by references. We pass structs and enums by value. Collections are passed by reference, so that we don't, if you have a large collection, it doesn't all need to be marshaled back and forth. And we can use shared memory with typed arrays. And answered the question earlier about tasks and promises. We propagate exceptions and stack traces. So if there's an error thrown in your JavaScript, it can bubble up through .NET and back to JavaScript, and you get the full stack trace. We can marshal streams, so map between .NET streams and Node duplex streams. I mentioned before how you can implement an interface in JavaScript and pass that to .NET. And you can also do the reverse. So if there's a TypeScript interface, you can implement that in a .NET class. In order to bootstrap the .NET runtime, .NET has these either MS Core EE or HostFXR APIs, which are kind of COM style APIs for loading .NET. I see a hand raised, Kevin.
Yes, I had a question regarding the marshalling, because last time I played around with Core CLR, I got into a problem with methods that are overloaded.
Yes.
Do you have support for that?
Yes, we do support overloaded methods mostly. So we can, it's a very common practice in C# to have overloaded methods. So you have multiple implementations of method that take different sets of parameter numbers, different numbers of parameters, different types of parameters, and then the method may behave differently. It's unlike JavaScript where you can only have one method with a given name, and it may inspect the parameters passed in and behave differently depending on those. And TypeScript kind of makes it look like you can overload, you can have method overloads, but they're not true overloads.
Mm-hmm.
So anyway, in the case when we have a .NET overloaded method that's projected to JavaScript, we dynamically generate the overload resolution code. So we can look at the number of parameters that you pass into the method and also the JavaScript type. Currently, we just look at the JavaScript basic type, whether it's a string or a number or a Boolean or so on. So we can resolve most overloads that way. The limitation we currently have is if there's a .NET method that has overloads that differ only in different classes of objects.
Yeah.
Distinguish those yet. I think we could do more there, but that's the current limitation.
Gotcha. Okay. Thank you.
Another question, sorry, before you continue.
Go ahead.
It's kind of a nitty-gritty one. How do you deal with things going out of scope in JavaScript? Like, does .NET have like a similar memory model where it's like garbage collected, or that's usually the dirty part of it.
Yeah. So .NET is also garbage collected. So we use the Node API capability to set up the finalizer. So let's say you pass a .NET object to JavaScript, and then the JavaScript reference to that goes out of scope. Then the finalizer will release the GC handle to the .NET object, so it allows the .NET to garbage collect that object.
Ooh, what about the other way though? Like, how do you tell JavaScript that your variable is all of a sudden empty? Like if you pass something into .NET and it goes out of scope in .NET and it gets garbage collected, how do you inform JavaScript?
Vladimir, do you know if we have a good answer to that? I can't remember now.
So first of all, because Node API mostly works with stack-based values, right? We have some guarding mechanism, which I think originally was borrowed from how Rust does it. So technically, every single wrapper for an API value has also reference to the scope. So every time we want to kind we use JavaScript from C#, we check if scope is valid or not. So in this case, we make sure that we never use this kind of dangling reference to an API value. So
right, and if you do want to keep a reference, then you create a nappy ref, which in .NET is an idisposable, meaning it can be explicitly disposed.
Right.
Oh, okay, gotcha. Okay, so you keep the JavaScript object around until .NET is ready to let go of its side.
Yeah, but in that case, it has to be more explicit management of the lifetime.
Gotcha. Cool. Thanks.
We'll have two scenarios. Value, it will be effectively kind of clean up automatically because of this call stack, right? I mean, JavaScript value will be clean up. But if we have reference, like Jason said, we need to use a kind of explicit dispose call. Or if, for example, C# object which wraps up with JavaScript object, if it's garbage collected, then as a part of this garbage collection, again, we call this, we can't call dispose, we call dispose, but we can't release nappyref because we can be in some random GC thread. So what we do, we kind of post this release to JavaScript thread. So we schedule this release there. But
okay, understood. Okay, yeah, that makes sense. Yes, thank you.
Yep. So this slide is about how we bootstrap the .NET runtime using these APIs. So .NET has some kind of COM style APIs, which we can call from C# to bootstrap the runtime. So we write C# code, which loads the .NET runtime, which sounds kind of funny, but actually that C# code then is compiled to native binary using ahead of time compilation. So we have basically this native shim, which takes care of loading .NET when you want to call it from JavaScript. Alternatively, you can compile your whole node add-on module ahead of time. And we use a feature of .NET called source generation, which can emit C# code at build time, so that then that generated code can be compiled ahead of time into a binary, so that all of our automatic marshalling code can be generated ahead of time and compiled ahead of time to a binary. So then at runtime, there's no dynamic code generation. You just have a binary that can marshal between JavaScript and the ahead of time compiled .NET library. However, we can also dynamically generate marshalling code at runtime if you're running on .NET runtime. So if you're not doing ahead of time compilation, you just want to do FFI style dynamic invocation, then we can dynamically generate marshalling code. And we share this code generation between build time and runtime. The way we do that is we generate .NET expression trees, and we can either emit those expression trees as C# code, or we can compile those expression trees at runtime into .NET delegates. And we do a lot of optimization for interop. We try to make marshalling as efficient as possible. This code generation allows us to either compile the marshalling code ahead of time or compile it once at runtime and then use that compiled code thereafter, so that it's very fast. And we try to minimize heap allocation and copying when possible. So this is a performance comparison to Edge.js. So Edge.js was kind of the existing way to interop between .NET and JavaScript. It doesn't have a lot of the capabilities I talked about. It's pretty basic in terms of what it gives you to call between .NET and JS. And it's also not as fast as what we've done because it doesn't do any of this code generation stuff. It basically does reflection at runtime every time you want to marshal something back and forth. Simple interop is about twice as fast as Edge.js. And then this is also comparing cold and warm starts. So ahead of time compilation for this scenario is of course much faster to start up because it doesn't have to do any jitting. It's even faster than the baseline, which is doing all the same thing in JavaScript because JavaScript also requires jitting the code. So by writing the code in C# and then compiling it ahead of time, it starts up much faster than if you were just to write the same code in JavaScript. So we're still working towards what we consider a V1 release, hopefully this fall. We have issue tracker and open to contributions for anybody who wants to get involved.
Quick question. Is it available on NuGet?
Yes, it's published to NuGet now. And there's...
I remember last time I was looking around at it, I was like, oh, this looks cool, but I couldn't figure, I don't think it was published yet. So, but if it's published now, maybe I'll take another look.
It's on NuGet and NPM, so technically we have both.
Perfect.
Yeah, so, right. So primarily the starting point, if you're starting from JavaScript, you would reference the NPM package. But if you want to set up that build system, if you have a more complicated project with lots of dependencies in .NET, then you would reference the NuGet package also. And there are, in our docs folder, there are some docs about setting up a project. There's a step-by-step guide for setting up a project and how to reference the NuGet packages and so on, so you can follow that.
Perfect. Thank you.
And this slide we were showing it also in docs folder.
So I mentioned we have some teams in Office who are starting to use this. I expect we'll get more adoption within Microsoft as this project matures and more people find out about it, because .NET and JavaScript are both very widely used within Microsoft, and I expect more teams will want to do some interop scenarios.
Very interesting.
And all you saw, like this using Node API gives a lot of perf gains compared with any previous approach people have tried. So it's Node API is a winning technology here.
That's really, yeah, it's nice to see that it's opened up like things that maybe we didn't even think about in the beginning, right? Like, so cool.
Yeah, and I think the TypeScript generation, are there any other Node API projects that do a similar kind of thing, generate type definitions for APIs in some other language that are exported to JavaScript?
I'm not aware of any. I think there were a few other projects that were generating wrappers, but I don't think that they were using TypeScript necessarily. So it isn't, that's definitely an interesting thing. If there was like a bunch of back ends to that, hey, you can generate your wrappers for JavaScript, or not for like, for .NET, generate your wrappers for C++ or whatever, I could see there being like the front end part should almost end up being the same, right? Although maybe that's not practical. I don't know. It does. Do you think like the .NET what's generated from .NET could be the same as what you would generate for C++?
Yeah, I don't know, because as part of that generation, you need to kind of understand the dependency tree of .NET, right, which requires the .NET tooling.
So it's letting you, right? The wrappers are not like a generic invocation interface. They're like, here's an interface that lets you invoke .NET from JavaScript, and like some of the types and names and everything make sense because you're going to .NET as opposed to being generic.
I think so. Yeah.
That kind of makes sense. It's like I can see like on the Node API side, it's like you're writing JavaScript in those other languages, but you still got to know the JavaScript concepts, right? And then I can see the reverse being true. It's like, well, I want to call .NET things, but I need to know the .NET concepts, and those might be different from the C,
yes,
C++ concepts. So yeah, okay.
For what it's worth, I can think of one way, even in just simple C++ to JavaScript, where we could generate type definitions, and that's during the add-on loading process, right? Because the add-on, like in its init function, right? It'll like define classes, and it'll define functions and so forth, and we could intercept the calls made between the start of init and the end of init to Node API, and we could generate types from that. They would not take into account any of the underlying concepts, as you pointed out, Michael, but it would be at least a level of typing that would be specific to JavaScript and agnostic of the system behind it, but it would be more generic because it would work for any situation where you have like an init step for creating a bunch of JavaScript objects which represent your API.
Yeah, I think I was just poking at whether there's something like, not the solution for C++, but like if those classes that were generated were generic. But I think I understand, like having just had this discussion, it's like what you get in terms of those TypeScript definitions is probably going to be pretty closely tied to .NET. And if you did something similar through introspection for C++, you would probably have something which is more tightly coupled to C++ than. But it's just that it's definitely an interesting. It's interesting that's like having the TypeScript. The value of like the TypeScript usage in terms of like, hey, you've got the types, you've got like the comments and all that kind of stuff could actually be common. Like that common concept is really interesting. I think you mentioned one of the things, and we've only got a few minutes left, was just you did use the lib.node.js APIs that are in the PR. So I don't know if you wanted to say more about that at this point.
Yeah, I think Vladimir has talked to you about that PR. It would really benefit our project to get that merged into Node. Right now, we are building libnode from this PR. And it'd be great if we could just build libnode from a release tag of Node, or even better, if Node.js itself would build libnode binaries and publish those somehow.
So that I personally think is great, but I don't think that's going to happen anytime soon. Like every time we try and talk about publishing new things, it's like, well, we're barely keeping up with what we have published today. So adding something new,
yeah.
But getting something in there, I tried to look at it, and I think getting that unlocked would be good. My current thought was, can we try and remove one of the concerns about like it not being ready to be ABI stable yet? So move those APIs so that they're not part of Node API, but they use Node API types. And so like they're, Node API should be our API in terms of interacting with JavaScript, but these specific methods might be outside of it for now. So no ABI guarantees. I tried to pitch that that's an easier way to get that landed. I don't see any discussion on that, but I think if we could get the PR into that shape, then we might be able to push a little bit harder in terms of like, okay, we're not making any ABI stability guarantee now. So in terms of it being the right thing or wrong thing forever, let's not argue about that. Let's say it's something that we know people are using, get it in there, and then make that sort of okay, there's something you can try out, try it and complain. I think to me, at least, that seems totally reasonable, right? But I don't think we've got the PR in the shape where we could say, okay, that is the shape. And because nobody's commented, I don't know if they'll then complain after once we get it to that state. But that's what I would push on next, is getting to the state where we can say, don't worry about the ABI guarantee, because we're not promising that. It's just a C in better API, just like the C++ one, which could change.
Yes. Yeah, so I think the original PR author might not be able to continue working on this, so it might take one of us kind of taking over that to move it forward.
Yeah, I think, like, it might be just like, if one of you two wanted to jump in and say, hey, we think the suggestion that Michael posted in this comment makes sense. Momachev, do you have any concerns if we push some commits to move it in that direction, right?
Mm-hmm.
And unless he's like, no, don't do that, which I'm hoping he just would see that as help, right? Like he would say, yeah, okay, sure. And then, you can jump in, push it forward, and hopefully we can then, like, if it was in that state, I would be like, okay, yeah, I'll +1 that as it's not an ABI guarantee. Let's get this landed and we'll see who else. And I guess, like, Shenzong, I don't know, or Gabriel, like, would you be comfortable also like +1ing it in that form?
Sure, I'll do more reading on the PR and I'll comment appropriately.
Because I think if that's three, that would be like 3 collaborators within the project saying +1, and so somebody would either come and say, no, I want to block this, or yeah, we'll let it through. And I'm hoping with it not being a ABI guarantee forever, it's easier for people, even if they are a little uncertain if we've got it right, to say, yeah, okay, let's that go in, because we're free to change it later if we find it's wrong.
Yeah, there's just pure value that being C-based API. As you see, we can use it from C#, any other language. So technically, this the whole usefulness of libnode from other environments become much more useful.
Yeah, and I used it in an experiment where we were like invoking WASM from crun. So just having that C API, I think, is very much important for Node. So. Okay, I think that takes us we have 2 minutes, so I don't know if there's anything like urgent that we should discuss instead of deferring to next week.
Maybe we can squeeze in this one PR if nobody else has anything.
I just have a quick PR announcement on Node add-on API, the one for dropping support for version 14. I pushed that. So if people have time this week and take a look, that'd be great.
Okay, so that's the one that, yeah, yep, sounds good.
Sounds good.
Gabriel?
Yeah, 48339 in the core repo. It's for exposing external strings. So if you go to the bottom, I've been getting reviews from Dion, and one of the things that we should talk about is whether we should add the ability to attach finalizers to the strings, which are called from the implementation of dispose in V8. I tend to agree that it would be useful, because then you could treat heap allocated strings as externals as well, and the finalizers would be pure, because that's how we decided to do finalizers. So I don't think it should be a problem. The other one that we should probably think about, even if we don't thrash it out right now, is whether it's like a best effort whether you copy the string or not, right? And if you do copy the string, then Dion is suggesting that we immediately call the finalizer because there is a copy. And so shall we do that transparently, or shall we have like a new status that says the string got copied That may be problematic, because most implementations, I would think, are like, if the return value is not an API okay, then throw. So some of these things that we could think about for the next meeting.
Yeah, I think in that case, like, I don't think we'd have a new status, but you could have a Boolean that you you pass in a reference to a Boolean that gets updated if that was important.
Oh, that's a great idea. Yeah, whether it was copied or not. Okay, that's good. Yes. And if it's null, then you don't care. Yeah, okay, cool. Yes, thank you. That's a great idea. Let me write that in before we lose this idea.
Okay, so I think at this point, yeah, I've that's been in my list of interesting ones to look at, but I haven't looked at it. Given that we're at time, I'd suggest like it's more of a call. Everybody take a look, and we can maybe discuss next week.
Absolutely, thank you.
Okay, well, thanks everybody. In particular, thanks Jason for coming. That was really interesting, and it's great feedback. At least for me, and I think probably for the rest of the team, to see Node API being used in these new and interesting ways, and just what it's enabling. So that's thanks a lot for coming. And we'll see everybody in GitHub next time.
Thank you. Bye.
Thanks.
Nice to